A bat can navigate a pitch-black cave at full speed, dodging obstacles it cannot see, using nothing but sound. It's the only true flying mammal on Earth, covering hundreds of kilometers a night. And it carries some of the deadliest viruses ever recorded in human history. Ebola, COVID-19, SARS, inside its body, without being affected. We fear bats. We've blamed them. But biologically, they are doing things we cannot fathom, let alone replicate. Today we're looking at bat abilities that would change what it means to be human, and what life would look like if we can do them too. Welcome back to What If We Evolved. This week, the bat. What makes a bat so extraordinary? Bats are the second largest order of mammals on Earth, over 1,400 species, found on every continent except Antarctica. They pollinate plants, control insect populations, and disperse seeds across ecosystems that would collapse without them. They are one of the most important animals on the planet. They also live extraordinarily long lives for animals their size. A common bat weighing less than a coin can live for 40 years, defying every biological rule that links body size to lifespan. They enter states of deep torpor that drop their body temperature, conserving energy through winter months with extraordinary efficiency. Some species roost in colonies of millions, navigating in total darkness without a single collision. And their bones, paper-thin, hollow, built for flight, are proportionally stronger than steel. But today we're not talking about any of that. Today we're looking at echolocation, flight, and an immune system that carries the deadliest viruses on Earth without consequence. Echolocation. Bats navigate using echolocation, emitting ultrasonic pulses at frequencies between 20,000 and 200,000 Hz, and interpreting the returning echoes to build a precise three-dimensional map of their surroundings. Different bat species have evolved different echolocation strategies, some optimized for detecting moving targets, others built to extract detailed information about the shape and texture of surfaces. The returning echo contains an extraordinary amount of data: distance, size, shape, surface texture, and velocity of an object, all processed simultaneously in real time. What makes this even more remarkable is that bats using echolocation in large colonies, sometimes millions of individuals, can isolate their own calls from the returning echoes of every other bat around them, processing their own signal without interference. It is one of the most sophisticated biological sensing systems ever documented. For the blind and visually impaired, this ability is not hypothetical. It is a glimpse of something already partially achieved. Some individuals have trained themselves to use a basic form of human echolocation, clicking their tongue and interpreting the returning sound to navigate. But the resolution is limited, the range is short, and movement is slow and cautious. A bat-human's echolocation operates at a completely different level. The biological system processes returning signals automatically, instantly, and at a resolution no human has ever achieved through training. A blind bat-human doesn't navigate carefully around a familiar room. They run through an unfamiliar one. They build a complete, continuously updating picture of their immediate surroundings. The position of every object, the shape of every surface, the gap between the furniture and the wall, assembled from sound alone, in real time, without effort. Not as a workaround, as a sense. Flight. Bats are the only mammals capable of true sustained powered flight. Their wings are formed from a thin elastic membrane called the patagium, stretched across dramatically elongated finger bones and extending from the body to the hind limbs. The membrane is not passive tissue. It is densely packed with sensory nerve endings that detect changes in airflow, pressure, and turbulence in real time, feeding continuous aerodynamic information directly to the nervous system. This allows bats to make micro-adjustments to wing shape mid-flight that no engineered aircraft can replicate. Bats can reach speeds exceeding 160 kilometers per hour, execute turns in under a tenth of a second, and sustain flight across hundreds of kilometers in a single night. Their energy efficiency in flight is among the highest documented in any flying animal, achieved through a combination of wing geometry, membrane elasticity, and the ability to recover energy from their own wing beat cycle. For a human with this ability, the most immediate change is the elimination of distance as a constraint. A rescue worker reaches a disaster site in minutes regardless of road access. They don't wait for roads to clear. They land directly at the site and begin administering aid to victims while ground teams are still navigating their way in. Picture the average Monday morning commute, a city of 4 million people, all trying to move through the same roads at the same time. The average urban commuter spends roughly 40 minutes each way, over 200 hours a year sitting in traffic, on platforms, or in queues. Time spent doing nothing, going nowhere. A bat human doesn't use that system. They step outside, take off, and fly in a straight line to where they need to be. No traffic lights, no intersections, no delays. A 40-minute commute becomes a 6-minute flight. Those 200 hours a year come back, allotted to sleep, to family, to work, to anything other than waiting for the car ahead to move. Viral coexistence. Bats are the confirmed or suspected natural reservoir for some of the most dangerous viral pathogens ever recorded. Ebola, COVID-19, SARS, MERS, Nipah, and Marburg among them. In every case, the bat carries the virus as a persistent infection without developing disease. Most mammals, including humans, mount an inflammatory immune response when a virus is detected. Inflammation is a key part of how the immune system signals threat and recruits defenses. In bats, this inflammatory response is structurally suppressed, either absent or significantly downregulated. At the same time, bats maintain a constitutively active interferon response, interferon being the signaling protein that triggers antiviral defenses. In humans, interferon production ramps up after infection is detected. In bats, it is always on. The virus enters a system that is already fully primed and responds immediately, before the infection can establish or spread. The result is an immune system that is simultaneously more aggressive in its antiviral response and more restrained in its inflammatory output than anything found in other mammals. COVID-19 killed over 7 million people and shut down the global economy for years. Ebola kills up to 90% of those it infects. Both originated in bats, animals that carry these pathogens indefinitely without consequence. A bat-human immune system, interferon always active, inflammation structurally suppressed, antiviral defenses permanently primed, doesn't manage these infections after they establish. It neutralizes them before they can. During COVID-19, the world shut down for years. A bat-human population doesn't shut down. It doesn't even register the threat. The pandemic that reshaped human civilization becomes, for a bat-human, background noise. The bat has spent millions of years being misunderstood, feared, associated with darkness, disease, and death. And in a deeply ironic twist, it turns out the animal we blamed for some of our worst pandemics is also carrying the biological answer to them. An immune system so advanced it makes our own look like a rough first draft. It navigates in total darkness with a precision no technology has matched. It is the only mammal that ever learned to fly. And it survives, quietly and indefinitely, alongside the viruses that have shaped the course of human history. We spent centuries being afraid of the bat. Maybe we should have been taking notes.